What is a neural network? Well, we all know what artificial intelligence is. We're all using it on a daily basis with things like ChatGPT, which is a large language model. So if we drill into that and we come down, they're all based on a neural network. So what exactly is a neural network? Well, we're going to get into that. So what is artificial intelligence? What is machine learning? And what is a neural network? Well, artificial intelligence, and I quote, is programming systems to perform tasks which usually require human intelligence. So it's something a little bit more complicated than just a machine, but it's actually doing something that a human would normally do. Going down a level into this, what is machine learning? So it's training algorithms to solve tasks by pattern recognition instead of specifically programming them to solve the task, which is what you would normally do with traditional computer programming. And then deep learning, or DL, training algorithms by using deep neural networks with multiple layers. So let's dig into that a little bit more. So traditional programming versus machine learning. Let's say, for example, we needed to understand the pricing of houses in a city, for example. Now, the way you would do that in traditional programming is to have your input data, which might be the house square footage, the number of bedrooms, bathrooms, property location, property size, all those sorts of things. We would call that the data. And then we would run a program which would say the more bedrooms there are, the more price the things would go up, and so on and so on. So you're going to be predicting the price based on the input data that you have. That's a traditional way of doing it. Machine learning does things the other way around. It takes all the same data but pairs that with the actual results, so the actual sale prices, and then it runs against those input and the data and creates a model or patterns based on that. And so that model is then created that can be used to then predict the outputs. Machine learning has some advantages. One of the main advantages is that it can take complex things where there are patterns that couldn't normally be seen by describing a program. On the other hand, a program is very explicit on exactly how it functions, and a machine learning model is not. So they're the fundamental differences in those two techniques. Well, what is the fundamental structure of a neural network, and particularly a deep learning or DL type neural network? Well, there was a fundamental element called the neural node. These nodes are structured into layers from the input layer to the output layer. And when you get into two or more layers, it's called deep learning. Each one of those nodes has inputs and an output, weights, and a transfer function. What is a neuron and how does it work? Well, a neuron essentially has inputs and outputs, and then it has what's called weights, biases, and an activation function. Now, to define such a neural network, the inputs and the outputs layers have to be defined, the number of layers, the width of the layers, and the individual activation functions. And that overall structure or foundation model is what sets up the neural network. Then the second stage is to train that model with data. And it does that by looking at the data and comparing that with the outputs and then running through this training routine many, many times. And what's changing? The weights and biases. And so it's those weights and biases on top of that foundation model, that structure, which ultimately creates the model. Putting this all together, to train a model, we need to get the data ready. There's a pre-processing function to get it ready. We need to set up the structure, which we talked about with the activation functions and the number of layers and the inputs and outputs. Then the training process can begin, and it's then now looking for patterns, and those weights and biases are being set and adjusted as we go through. And after each cycle, we look at what's called a cost function, which is essentially how far off we are with the outputs for what we desire. Then that goes back through a process called back regression, which suggests changes to the weights and biases. And then we train that again and again, and we get closer and closer and closer, producing a better and better cost function until we get to a point where we feel the model is ready enough. At that point, we test it with the data, and if it's looking good, we go forward to a final validation test. Those are the sort of ways of doing it and some of the key things that I think help you understand, I hope, how a neural network works. And thanks for listening.